Zane, remember the last time we were together, we talked about areas of some plane figures. We talked about areas of some plane figures. All right, who can remind us the plane figures we talked about? Yes, is that Memphis behind? Okay, so remove your hood. You remove your hood. Remove the hood on your hand. Let me see your face properly. Yes, Sophia, can you tell us one of the places you talked about? Is she saying something? Because I can't hear anything.
Not yet. Parallelogram.
Okay, we talked about parallelogram. Okay, yes, that is correct. We talked about parallelogram. Yes, who else is going to answer us? Yes, Dara, what plane shape did we talk about?
We learned about trapeziums.
Trapezium. Okay, trapezium. Okay, yes, Christabella.
Triangle.
Triangles. Okay.
Yeah.
Now, before now, you've learned about squares and rectangles, right? You've learned about rectangles. So all of this, you know their areas, okay? Yes, Dara, talk to me.
Instead of writing squares and rectangles, you could also label them both in a group called quadrilaterals.
Okay, squares and rectangles are not the only quadrilaterals, all right? A quadrilateral is any shape with four sides. So basically, parallelogram is a quadrilateral, trapezium is a quadrilateral, square is a quadrilateral, diamond is a quadrilateral. You see that now? Kite is a quadrilateral, rhombus is a quadrilateral because it has four sides. So we talked about area. Jeffrey, is Jeffrey? Oh, okay. So we learned about areas. I would say a plane shape is a flat surface shape. And when you're talking about the area, you're talking about the area enclosed within the shape. But today we are going to be looking at something different, which is an extension of area. We're going to be looking at volume, volume of 3D shape. We're looking at volume of 3D, volume of 3D. Guys, put this down, put the title of what we are going to be looking at today. Put it down. Put down the title. Volume of Chris, what are you talking about?
He's saying how can a volume of a 3D, like how does a 3D shape make noise? Because he's thinking of volume as in noise, not like.
Hey, I was going to ask what volume means. Okay, now in science, all right, in science, when we're talking about volume, we are not talking about the sounds that comes from your TV, the sound that comes from your phones. Oh, can you get the volume louder? Oh, it's too loud in here. Can you reduce the volume of the TV? That's the volume we're talking about. All right. So Emmanuel, is that Memphis behind?
Here.
Yes.
Yeah, that's Memphis.
Yes, Memphis, tell us what you think volume is.
I think volume is the mass of something inside the shape.
Mass of something inside the shape. Okay, guys, let's give Memphis a clap, a single hand clap. Okay, so let's try it again. Everyone, want to go a single hand clap? Very good. So let someone else try. Tell us what volume is. Yes, roll Chris.
Volume is like when it can be, I think it was the height and like what inside the shape, so the extra inside.
Yes. Let's give roll Chris two claps. Two claps. Very good, because he mentioned what is inside a shape. All right. So Dara, talk to us. What do you think volume is?
I think that volume could be the amount of like what you could feel inside a shape
The amount of what?
of weight you can feel inside.
Okay, that is very good. Of quantity or amount, but there is something we need to talk about when we are talking about volume. So volume is the amount of liquid in a container. So volume is the amount of liquid in a container. Okay. All right. Now, in talking about volume, we have to understand what capacity is. Jeffrey, can you stand? Okay. So now, capacity. What is capacity? Okay. Capacity is the amount of space. Capacity is the amount of space in a container. So let's see the difference between volume and capacity. Volume and capacity. All right. Volume is the amount of liquid in a container. You see that? Whereas capacity is the amount of space in a container. For instance, if you have an empty bottle, all right, and the bottle is a 1 liter bottle. You've got a 1 liter bottle, and it is empty. All right. The capacity of the container remains 1 liter. Okay, let me make a sketch of a container here. Let's make a sketch of a container here. All right, and then so this is 1 liter. 1 liter. Right? This is empty. This is an empty container. All right. Now, if you put liquid inside of this container now, all right, the amount of the liquid becomes the volume. All right. But the empty container, all right, it can contain 1 liter. It has 1 liter of space. All right. So when you're talking about volume, it is the amount of the liquid in the container, whereas the capacity is the amount of space. All right. Now, all of you, those of you in the front room with a water bottle, can you look on the inscription of your water bottle and tell me the capacity of your bottle? Tell me the capacity of your bottle. Yes, just E.
500 mil.
500 milligram or milliliter. Right? Okay. Yes. Reese.
250 milliliters.
250 milliliters. Okay, very good. Yes, Sophia.
650 milliliters.
Did you say 650?
Yes.
650 milliliter. Okay, yes, Jason A.
I think mine is 780.
Fine. Show us the bottle and look around it. It is reading some. Yes, what do we have beside Memphis?
All right. And mine is 330 milliliters.
300. Did you say 70?
No, 330.
330. 330 ml. Okay. Yes, Jason A.
It is 780 milliliters.
780 ml.
Everyone has tiny bottles.
Okay. Yes, Christabella, what's the capacity of yours?
Oh, mine doesn't have a capacity.
No, it is written somewhere. You just
Mine don't.
yes.
Herman, it would have been on the sticker when she first got it, but it doesn't show on the actual bottle.
True. Yes, Rachel.
Mine is 1.06 liters.
0.06 liter. This very good. Yes, Rodocris, what is yours?
500 milliliters.
500 milliliters. Guys. Yes, Chris.
Mine isn't 250, it's 650 as well.
It says what?
Mine isn't 250, it's 650 as well.
650? Did you say 650?
Yeah.
Okay, 650. Okay. All right, Jemima, go get pencil. So, guys, all of these. Now, let me ask you a question. Those of you in the front row, is there anyone whose bottle is empty? Is there anyone whose bottle is empty? Oh, Reese, yours is empty, right?
But it's almost empty, it's just that one sip.
I want
It's sipping.
yours is empty, right?
This is literally.
Jason's is empty.
Okay, yours is empty. Now, because it is empty, does that reduce the capacity of the bottle? Does that mean it is no longer 780 mil? So, point is, capacity is constant. Volume is it depends on the liquid in the container. So Jeffrey, sit now and make sure you don't doze off again. All right? So, okay, everyone, I want you to write what volume is and what capacity is. So, volume is measured, volume is measured in cubic units, like centimeter cube, millimeter cube, right? Meter cube. Yes, Rhoda, please.
Can we also draw the container, the one that you drew 1 liter empty?
Draw that. You don't have to draw that.
already.
Okay. So, but capacity is measured in that. Okay. Yes, what is it? Read, talk to me.
You know when the top when it says volume is measured in cubic unit, like 3 centimeters.
No,
Yeah.
this is what it means: centimeter cube, meter cube, meter cube, and the likes. Yes, Reese, talk.
What I meant was that why couldn't it be like milliliters cube because it's volume?
Why can it not be milliliters cube?
Yeah.
No, I didn't say volume. What you checked on your bottles is not the volume. You weren't paying attention when I said Jesse's container is empty. Still, the bottle is still, the capacity remains. But the volume in it depends on the liquid you put inside. Does that make sense now, Reese? So capacity is measured in liters. So other units, Christabella, hold on. Other units are milliliter, that is ml, centiliters, and that is cl. So, yes, Christabella, talk to me.
So technically saying the reason why Jason's is still 500 is because that's how big the bottle is. But since it's empty, that's the volume.
Okay, now exactly the point I'm making is that Jesse's bottle has a capacity of 500 milliliter. It doesn't matter if any liquid is inside or not, because capacity is simply the amount of space. Do you see that now? But when you now put water in it, the water depends on the volume in it, all right? So you can put 1 cm cube of water in the container. If the space is available, it will contain it. You can put 20 cm cube. If the space is available, it will contain it. But you cannot say milliliter cube. That is incorrect. So let's take this out of the way. Capacity equals volume divided by 1000 cm cube. Volume in cm cube is divided by 1000 in cm cube. So quickly, I want us to work out capacity. Write this down, write this down. Yes, all right.
I finished.
Okay, good. Jemima, can you turn on your video, please? Let me see your hand up if you're done. Put your hand down, put your hand down. Right? Okay, quickly. Let's do something. Yes, Dara, talk to me.
No, I was just moving the light because it was in my eyes.
Okay. Quickly, let's do something. Calculate the capacity of a bottle if the volume if the volume of water in it is 250 cm3. 250 cm3. All right. Now the volume of the water in the bottle is 250 cm3. All right, do that. So you have to calculate the capacity of the bottle. Calculate the capacity of the bottle. Remember what I said about capacity? I said for you to calculate capacity, solution. I said capacity is volume in cm3, right? Divided by 1000 cm3. How many of you put this down when I ask you to write it? If you wrote this down, can I see your hand up? Very good. So, Rachel, please go use the restroom. All right? So, we want to find the capacity of this bottle now. That would be volume of the water, which is 250 cm3 divided by 1000 cm3. So, mathematically, cm3 would get rid of cm3. 0 will get rid of 0. All right. So, if you divide this by 25, this is 1/4. Okay. So you put it in. Put it in decimal. So that would be 1/4 is equal to 0.25 liters. Right? So the capacity is 0.25 liters. The capacity is 0.25 liters. All right? 0.25 liters. So if you want to know the capacity of any container, all you have to do is divide the volume of that container by 1,000. You divide it by 1,000. All right? So quickly, do this. Do this. How many liters? How many liters? Okay, Jeffrey, what part do you not understand? Talk to me.
I'm still struggling to calculate it.
We calculate 1/4.
Mm.
Huh?
Yes.
Okay, 1 divided by 4. Okay, how many 4 can you see in 1? Is that possible?
No.
No, so you put a 0 and then you follow it with a decimal point. And the moment you put a decimal point here, you add a 0 to 1. That makes 10. So how many 4 can you see in 10? Unmute yourself and talk to me.
2.
2. Is there a remainder?
Yes. 2.
Okay. Yeah, remainder 2. Because you are working with numbers after the decimal points, you immediately add a 0 to this. So how many 4 can you see in 20?
5.
Do you remember now?
Mm.
Okay. Well done for calling my attention immediately. All right. So how many liters of water are there in a tank whose volume is 10,000 or 100,500 centimeters? Okay. So I want you guys to work out how many liters. When the question is asking you how many liters, indirectly, what is he asking you to find? Yes. What is he asking you to find indirectly? If you say how many liters, what is he asking you to find? Yes, Reese.
The, the capacity.
Capacity. So you could either be asked, what is the capacity? Or you are asked, how many liters? Okay, so guys, do this in 2 minutes. 2 minutes, 2 minutes, 2 minutes, 2 minutes. So you're doing this in 2 minutes. Your time starts now. Yes, let me see your hand up if you've worked it out. Let me see your hand up if you've worked it out. Okay, Gabriella, Rudy, please. Okay, okay. Your time is okay, you've still got 1 more minute. You've still got 1 more minute to work out the capacity of the tank. The capacity of the tank.
That was 10. This number was 10. Make it just right. Could you move it once, because how many zeros after 1 0? But there's 3 zeros.
20 seconds more. Reese, Jeffrey, have you worked it out?
Yes, uncle.
Very good. Yes, Gabriela?
I think I finished.
Okay, you finished. Okay. Time's up, time's up. So, Gabriela, can you please work this thing out for us, Gabriela?
So I did 1 0 0 5 0 0 divided by
1 first, you need to say that capacity equals volume divided by 1,000. All right? Volume divided by 1,000. So what is the volume? Yes, Gabriela? Yes, Gabriela.
I think I got 1.05 liters.
1,00500 divided by 1,000. So let's do this together, guys. Let's see what we have to do to reduce this. So 0 will cancel 0. 0 will cancel 0. But then this 0 cannot cancel the one between numbers. So what you're left with is 1,005. That is 1,005 divided by 10. And that would give you 100.5 liters. 100.5 liters. How many of you got 100.5 liters? Okay, okay. Reese, what did you get?
1,050.
1,050. Oh, you did not divide properly. You did not divide properly. Okay. Jeffrey, did you tell Uncle Sean?
No,
Jeffrey, I'm going to say this.
I want to take your presentation.
No.
Man is not asking you something there.
Uncle Sean knows.
He knows. Okay, because
Yeah.
he told me. So I'm just going to move you to his class so that you can tell him. All right? I'm going to
Can you repeat that?
so that you can tell him. All right? Because he didn't tell me you were moving. All right?
Mm.
So, okay, so guys, you all got 1,105 100.5 liters. That is the capacity. So let's go back to volume now because our focus is volume. Now, when we continue working on volume, we would now be able to calculate capacity. But without losing focus of what we've got to do today, volume of a 3D shape. So let's see, volume of a cube. Okay, now volume of a cube. Volume of a cube. All right, so we've got a cube. Let's talk about a cube first. Edges. How many edges has a cube? How many sides? Oh, the sides and the edges are the same thing. How many faces? And how many vertices as a cube? Edges, faces, and vertices. So let's do a quick sketch of a cube. Let's do a quick sketch of a cube. All right. Okay. We've got a cube. Another cube. Right. Stop. How many edges on a cube? Who can answer this question? How many edges does a cube have? How many edges does a cube have? Okay, Jason A. How many edges does a cube have?
I think it has 16 or 18.
What?
16 or 18.
16 or 18 edges. 16 or 18 edges. Okay, who agrees with Jason A? Okay, who agrees with Jason A? I'm not sure I agree to. No, it does not have 16 edges. All right. Yes, Gabriela, how many edges?
8.
8 edges. Now let us see how many edges it has. So I'm going to put a red marking on the edges. So you are going to be counting how many edges are there. So guys, let's count. This is 1. Count with me. 2, 3,
3,
4,
4,
4,
5,
5,
6,
7,
7, 8,
9,
9,
10, 11,
and how many edges does a cube have? How many edges, guys?
12.
Edges. So a cube has 12 edges. Okay. Now, how many faces has a cube? How many faces has a cube? How many faces has a cube? Okay, all right. How many faces?
It has 6.
It has 6 faces. How many of you have seen a die before, or you play what is it called, Monopoly, or board games that has to do with dice, right? Each die has 6 faces. That is a cube. All right. Now, how many vertices? How many vertices does a cube have? Yes, Reese.
I think it might be 8.
It might be how many?
12.
12. Okay. Yes, Gabriela, how many?
8.
8. Let's count. Everyone, let's count. So I'm going to put a circle round the vertices. A circle round the vertices. So let's count.
1, 2, 3,
3,
4,
4,
5,
5,
And Gabriella is correct. It's got 8 vertices. All right. So all the sides or all the faces, okay, let's say a cube is made of 6 unit squares. Is made of 6 unit squares. All right, is made of 6 unit square. It is made of 6 unit squares. All right. So the volume of a cube is length times length times length. Now, guys, this is what this is length, and this is length. All right. So let me remove this so that it doesn't look too congested. Okay, so we've got the length, and length. And the volume of a cube is length times length times length. And it is in cm cube. It is in cm cube. Right, let's do something. Calculate the volume. Yes, Dara.
If when we go back to the cube, when you said a cube is made of 6 unit squares, what are unit squares?
Unit squares are 1 unit, right? 1 unit. If you are square like this, 1 unit, okay, 1, 1. All right. So a square now, or cube now is made up of 6. Does that make sense? Yeah. So the 6 is why we've got 6 faces for a cube. All right. Because each of the face is a square. Does that make sense? Good. So, calculate the volume of a cube whose face is 1 cm. 1 cm. Calculate the volume of a cube whose face is 1 cm. Yes, Roller Chris.
I don't understand.
You understand what?
Like the volume there.
The volume. The volume means we should since all of the are the same. All right. So it is a 3-dimensional figure. So we multiply the different dimensions. For a cube, you've got length, length, length. All right, because it's a square. Remember, it's made up of a square. This is length and this is length. The area of a square is length times length. Remember that?
Yes.
So for a cube is made up of multiple layers of square from the one at the base. So this is the square at the base, all right? And multiple layers having the height of L. So the volume would be to multiply all of the 3 dimensions, all right? So when we start with the example, you would see what we're talking about. So calculate the volume of a cube whose face is 1 cm. The face of the cube is 1 cm. This is very interesting, all right? So this is very interesting. We've got a cube the face is 1 cm. So what we need to do is say, what is the volume of solution? The volume of a cube volume is length times length times length. All right, and the face of this cube is 1 cm. It means this is 1 cm, this is 1 cm, and this is 1 cm. So meaning that we go 1 cm times 1 cm times 1 cm. Yes, Rhoda, please.
What about the fourth face?
Huh?
Because since there's 4 faces on a cube,
You can't see what?
I'm saying what about the other face when you've only labeled 3 faces?
All the sides are equal. All the faces are the same for a cube. Does that make sense? So anything you're writing on one part is the same for the other part. Does that make sense? But if you have the sides you can see, if a cube is facing you, you can only see 3 sides if a cube is facing you. Does that make sense? You can only see 3 sides, and those 3 sides are the same for every other side. Does that make sense? You can see only 3 faces when a cube is facing you. All right? So the volume of this unit is 1 cm cube. The volume is 1 cm cube for this. So let's see another. Yes, Dara, see me, talk to me.
Please, can I go to the toilet?
Okay, make it quick. The side of a cube is 12 cm. Calculate the volume of the cube. Calculate the volume of the cube. The side of the cube is 12 cm. Calculate the volume of a cube. Calculate the volume of the cube. Don't write yet. Don't write yet. Let's see. Let's figure this out. Now, this is not a unit cube. It is a cube of side 12 cm. The volume remains the same. So, solution. What is the volume of a cube? What is the volume of a cube? What do we need to find the volume of a cube, Sophia?
L times L times L.
L times L times L. And this is L here is 12 cm. So 12 cm times 12 cm times 12 cm. Okay, so what would that be? Everyone work it out. 12 times 12 times 12. 12 times 12 times 12. Twelve times 12 times 12. Yes, Rachel.
Is it 316?
No, it is not 360.
Oh, wait, look.
Yes, Joe.
1,728.
1,720. Did you say 720?
28.
28. So that would be 12 times 12 times 12 would be 1,728 cm cube. So you've got to put cm cube. All right?
Oh, yeah. Mr. Michael,
Let's talk to me.
I still don't get why we do it this way, but I understand the rule now.
Okay, you don't get why we're doing what?
Why we do it like this? Like why?
Why we multiply it?
Yeah. Not why we multiply the volume to get the volume because it's L times L. I get it, but I don't get why we do it.
Good. I like to tell children, you have water in your bottle.
Yeah.
Okay, can you open the bottle to see water in it?
Pardon?
I want you to open the bottle.
Yeah.
Okay, open it, make sure you don't spill water on the table. Can you try look inside and see the water?
Yes.
You see the water? Now, what is the shape on the surface of the water?
Pardon?
What is the shape on the surface of the water?
Circle.
A circle. Now cover the bottle. Cover it. Cover the bottle. Cover it. Cover it. Cover it. Cover it. Make sure it is tight. Now check the bottom of the bottle. What shape can you see?
Circle.
Circle. So that means once you start pouring water in your bottle, all right, it takes the shape at the bottom, isn't it?
Yes.
Very good. And the more water you pour in, what happens to the circle?
The bigger it gets.
Yeah, the more water you pour inside the bottle, what happens to the level of the water?
It rises.
Does it change the shape?
No.
It doesn't. Now, what does that mean? Rodriguez, the moment you start pouring liquid in a container, that liquid takes the shape of the bottom and it rises to a particular height. Does that make sense?
Yes.
Remember what your question? You want to know why we have to multiply all three L's. Does that make sense?
Yeah.
Very good. Now, what is the shape at the bottom of a cube?
Square.
Square. And what is the area of a square?
The area of a square would be the sides times itself.
Right. So if the side is L, so that would be L times L, right?
Yeah.
Very good. Now, if you decide to pour water inside of the container, inside of the cube, what happens to the shape it takes?
It will.
It will start rising, isn't it?
Yeah.
It keep rising and it will rise to the height, and the height is still the same as L. Does that make sense?
Oh yes, I get it now.
So the two L's, the first two L is the area, and then the third L is the height. So that is why we multiply the three L's together. Does it make sense to you now?
Yes, I thought of it because like centimeters cubed, there's a 3, but there's also, I think that might be why you have to multiply to 3L, because for square, there's also a square 2, but you multiply L by L.
L, yes. Remember I told you because we are multiplying units, centimeters times centimeters times centimeters, that is cubic centimeters. Yes, Jason E.
Bitch, could I go to the toilet?
Make it quick, please. So, guys, are you ready to do the next activity? Just one question. I'm just going to give you one question. All right? Who is ready for me? Very good. Try this. Try this. Only one question, but there are going to be two things to answer them. Okay, the face of a cube is 10 centimeters. Calculate A, the volume of the cube, and B, how many liters of water can it hold when filled up? C, how many liters of water will there
Right, don't need the question.
will be there and it is half full. Okay. You will try this question, and I want you to be careful because we have talked about liters, what you need to do to calculate capacity, all right? So I want you to do this in 5 minutes, Do this in 5 minutes. Do this in 5 minutes.
Mr. Michael,
Let's talk to me.
I finished.
All 3 questions?
Yeah.
You read them out.
I hope you put the units.
Yes.
Okay, very good. Jason A, tell me the good news.
I'm just scratching my head.
Thought you're done too.
Pardon?
I thought you were done. So keep walking.
Pardon?
Yes, all right. You're done?
Yeah.
Oh, I'm beginning to feel the time is too much.
Yes, I did.
I'm beginning to have that feeling that the time is too much, right?
Check. Really, because you might want to your measurement.
For what?
For some of your answers.
Pardon?
For some of your answers. I mean, not if you're a bit of you should have right. It was wrong.
All right, you've got 1 minute and 30 seconds to go.
That's it.
You're right.
Have you finished your work? You don't get feed. It says how many liters of water can it hold when filled up? That we're looking for the capacity. So
By 1,000 is
was it?
1,000 divided by 1,000.
There is so 1 watt. Remember, if you go down the cumulative capacity ratio, no, you'll see.
That's totally.
If you write down the capacity. Yeah. So the answer is always in
Small. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Stop. Stop. Okay, so Memphis, you're going to tell us the volume. Mr. Bella, you're going to tell us the capacity when it is filled up. And Joel, no, not Joel. Joel just answered a question recently. Reese, you're going to tell us when it is half full. How many liters will be there when it is half full? Okay, who's ready to roll? Who's ready to roll? Okay, who's telling us first? Who's working out the volume? Memphis, go on, darling.
So for the volume, I did 10 times 10 times 10, which was
10 centimeters times 10 centimeters times 10 centimeters. And what is that?
1,000.
1,000 centimeter cube. Very good. Yes. How many liters of water can it hold when filled? Yes, who's doing this for us? Christabella.
I divided 1,000 by 1,000 and I got 1 liter.
So you did capacity equals volume by 1,000, right?
Yeah.
That is 1,000 cm cube divided by 1,000 cm cube. And you got what?
1 liter.
1 liter. Very good. So, Reese, what happens when it is half full?
What I did was that when the volume of the cube was 1,000 and it says half full, so I did 1,000 divided by 2 and got 500 liters.
500 liters. Now you see what would make you why you're wrong. All right, capacity is liters, so you are not dividing the volume by 2. All right, it is the capacity you are dividing by 2 when it is half full. So I want you to look at the capacity now when it is half full. So that is half times capacity, right? Right? Reese, are you with us?
Yeah.
That would be equal to half times 1 liter. All right? And that is 0.5 liters. Yes, Rhodocris.
Do we get a break?
Are you supposed to get a break?
No.
We would.
Oh, you're supposed to get a break. Yes, Christabella.
You asked us a question. You said we wanted to get a break. I didn't hear you.
I did not ask who supports you go on break. I think, are you supposed to go on break? Okay, let's take 5 minutes break. 5 minutes. Be back 11:10. Be back 11:10. So far, guys, we've been able to look at volume of a cube, all right? And then we'll quickly look at 3D shapes now. One moment. Right? Can everyone see my screen now?
Yes.
Okay, so let me make it big for those in class to be able to see. All right, everyone should be able to see it now, right? If you can see my screen, can I see your hand up? Very good. And we want to see how to work out volume of these 3D shapes, combination of cubes. We've got combination of cubes. So let's see. But we need to first, we need to be able to find how many cubes make up the 3D shape before we can then find out the volume. Now, note one thing. I want you to put this now. Each cube is 1 unit. Each cube is 1 unit. So to make this 3D shape, each cube is 1 unit. So guys, let's see the first. This is you're not drawing any of this. I just want you to pay attention, all right? Because if I ask you to draw it, it's going to take the whole day. So nobody should draw it. But let's see how to count the cube. How many cubes can we see here? Let's count the first one. Okay, this is 1, 3,
4, 5, 6.
6.
So number of cubes is the number of cubes is what? 6.
Six.
Do that, or you look at it, is it a perfect cube? Is it a perfect shape that we can just multiply and say, how many can you see here? This is 1 and 2. Right? So you've got 2 on this side, and you've got how many on this side? 3.
3.
So what times 3 is 6. Does that make sense, guys? Okay, so what then is the volume? How many cubes did we see? How many cubes did we see? So that would be 6 times 1 cubic unit,
Yeah.
which is to 6 cubic volume. Yes, Christabella,
I don't get it.
you don't get it. Now, each of the cube is 1 cubic unit. So for you to the volume of 3D shape, you need to just count how many cubes are there in the shape. You need to count how many cubes are there in the shape. So once you know how many cubes are there in the shape, then you multiply by 1. That gives you the volume of, yes, talk to me.
So Uncle, technically saying if there were 4 cubes, would you times it by 1? Wouldn't that be 4?
Now, once each of these cube is 1 unit. That makes sense.
Yeah.
So let's assume each of the cube is 2 cm cube. If each of the cube is 2 cm cube, then the volume of the entire 3D shape will be 2 times the number of. Does that make sense to you?
I didn't hear you cut off.
Huh?
You cut off.
Okay, I said if, assuming the question says each of the cube is 2 centimeters cube, and you want to find out the volume of all of them, all right, you need to multiply this by 2. But this time around, it is 1. Now, let's look at, how many of you, okay, did you see ice cube makers? You know ice cube maker, right?
Yeah.
Ice maker, very good. Now, if you want to put water, right, in the ice cube maker, let's say the ice cube maker can make 20 ice cubes, all right? By the time you make the 20 ice cubes, do you ever see a cube that is bigger than the other one?
No.
No, they are always the same. That is because it is 1 cm cube each. All right? So if you want to know the volume of the all 20, you just have to do 20 times the volume of 1. That makes sense? Does that make sense, Isabella?
Yeah. Kind of.
Kind of. Now, it will make sense if when you get home and you see, oh, this is my ice cube rack. Water is on the same level, all the spaces, isn't it?
Yeah.
Yes, and by the time you put it in the freezer and it comes out as ice, when you bring it out, you remove the ice cubes. All of the cubes are the same. And if you want to know the volume of all of them, you just need to count how many cubes you made times the volume of 1. Does that make sense?
Yes, of course.
So let's see. How many cubes do we have in the second one? Gabriela, do you want to answer this?
I was going to say if the capacity that each cube was 2 units, that means would you do 6 times 2?
Yes, you would do 6 times.
Oh, I get it now. So say the cube was 2 centimeters, and then 4. Now do 2 times 2 equals 4. Yeah, I get it now. In this case, each cube was 12.
Does that make sense?
Uncle, I think I get it now.
Second one. How many cubes do we have in the second one? Let's count. 1,
2, 3,
4,
5, 6, 7, 8.
8. So cubic times 1, 8 1 cubic, right? And that is 10 cubic. Okay, now let's see. How many cubes can we see in the third? I want Ore to count it for us, and let's see. Ore, can you count how many cubes we can see in this particular how many?
9.
9. Okay, let's verify if it is 9. Everyone, let's count. 1,
1, 2, 3,
4, 5, 6, 7, 8.
9.
and something behind it is 9 cubes. So this is 9 times 1 cubic, okay? And that is 9 cubic units. So let's see this. Oh, this is a little tricky. This is a little bit tricky. So I want someone with an eagle eye to be able to count these for us. Dara, okay. Count it for us and tell us how many. So we are going to verify. Put your hands down, the rest of it. Dara will count for us. Yes, Christabella, you want to ask a question?
No, I understand it. So say the cube was each unit was 5 and there's 7 of them. Would that be 35?
That would be 5 times 7. Yes, that would be 35 cubic units. But most of in this at this level, each of the cube would be 1 cubic unit. All right. So Dara, how many? How many cubes did you count?
I've got 12 cubes.
12 cubes. Okay, let us see if there are 12 cubes here, everyone. Let's see if there are 12 cubes here. Everyone, cubes. So let us count. Now, this 1, 2. We've counted all of these. So let's go. This is 5, 6, 7,
8.
9.
this is 9 and 10. Now, if you notice, this 9 and 10 has another cube behind it. Did you agree?
Yeah.
So that is 11 and 12. So that makes it 12. That means this is 12 times.
It could also be 11 because we don't know if there's actually a cube behind 10.
Actually,
It's 4.
Yeah. 3-dimensional, right? So
That sounds so embarrassing.
when you have something like this part already shows you what is. Does that make sense? Good. So yes, talk, Gabriela.
I did a different way. So I counted how much was at the top, and then I times it by 2 immediately.
Okay. And how many? At the top, then you times it by 2, right? Because there are 2 layers. That is correct. Because we could have done this we took the first one as an example, right? So you see the height, and then how many can we see? So guys, this is going to be a quick work before I give you what to do finally, right? So what is the volume of the shape? Who is going to tell us? Jason A. What is the volume of this cube?
Wouldn't it be 8 cubic units?
8 cubic unit. Let's see how many are there. Guys, let's count how many. Let's count how many. So count. This is 1, 2, 3, 6, and behind that is 8. Or you can still do like this. How many faces can you see? How many faces can you see? We can see 1, 2, 3, and 4. Then times 2 layers. This is 2 layers times 2. So this is indeed 8 cubic units. Is 8 cubic. And the next one, Memphis. What you tell us the next one? What is the volume of this shape, Memphis? What is the volume? Huh? 24. Okay. It is indeed 24. Okay, pardon me. Can you give both Memphis and Jason A round of applause? Can you give both Memphis and Jason A round of applause? A round of applause, a round of applause. Okay, so how is it 24? Let us count. How is it 24? Let's count. On this level, we have 1, 2, right? And on this, we have 1, 2, 3, and 4. How many layers do we have? We have 2 layers. So 3 times 4 times 2. That would be what? 24. Or you simply count 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, so you either count or you multiply. So it is 24. What is this volume? E. E.
1, 2, 3, 4, 2 cube units. 1, 2, 3, 4, 5. It's 14.
Talk to me. Can Jason hear me?
Yes, Uncle. I got 40 cube units.
40.
Yes, Uncle.
Okay, guys, let us count. How many layers? How many layers? We've got 2 layers. Okay, let's see. How many do we have here? 1, 2, 3, 4, 5. How many do we have here? 4. That is, so guys, the volume is 2 times 4 times 5, and that is equal to 40 cubic unit. Now, guys, put this down. This is what I'm going to have you write now. This is a cuboid, all right? This is a, all right? The volume of a cuboid, volume is times width times edge. Remember, we multiply 3 dimensions. So this is the length. Let me show you the length. So for this cuboid, this is the length, this is the width, and this is the height. You see, I did this, and this. Length.
Mr. Michael,
Yes, talk to me.
do we draw the shape?
So don't draw the shape. Simply write the method, all right? Simply write the method. Yes, all right, talk to me.
I finished.
Huh?
I finished.
Okay.
That's the word. The length and the width being the same level. I don't really. The length and the width are on the same level. Oh, yeah. The length of the what? The length of the width. The length is only 4 and the width is only 5. The height is 2. The legs and the same length as the width is like 5 and the length is 4. I mean,
That's the width.
is yeah, but then the length is also on the same size.
No, look.
What?
No, because this is the width
Yeah.
and that's the length. Yeah, because that's the length. The length is 4. Wait, how is it 4 and 4? 1, 2, 3, 4, 5.
See that? If they're both the same number, it'll be
Look,
square.
1, 2, 3, 4, 5. 1, 2, 3, 4.
Let's solve the problem. You want? Let's solve the problem. Okay, this is, let's count 1, right? 2, 3, 4, 5. The problem? Does right? That is the width. Let's check the length. Let's check the length. 1, 2, 3, 4. Solve the problem?
Yeah.
So, guys. Yes, Sarah, talk to me.
I think what they're trying to say is because they go across each other, so they're thinking that it's the same.
Oh, no. It's when you're working on the number, the length, the width, all right, intersection is allowed, all right? If you have a line this way, you start measuring from here, and from here, right? You don't say because you have from here to here, you're not measuring from here, no. So, okay, I want to give a question on this volume we just I just gave you now. So calculate, okay, let's see. Cuboid is 5 centimeters long, 7 centimeters wide, and 6 centimeters high. Calculate the volume. This is A. Calculate volume. B. How many liters what and heat O. Okay, a cube 5 centimeters long, 7 centimeters wide, and 6 centimeters high. All right. How many volume? Calculate the volume of oil and find out what amount of liters can hold.
Mr. Michael, I finished.
All right, roll it, please. I'm very sure you had worked the question even before I finished writing the question. So you're trying to tell me you know what I am thinking. Okay, all right, it's finished too.
Yeah.
One shot of the one. I think you do 1 mark. 1 mark between us and give me another question. Where's your units? That means 0, right? But don't worry about that. You're laughing.
See what the answer will look like. The volume is length times width times height. And that's 5 cm times 7 cm times 6 cm. This would be 5 times 6 times 7. That's 100. How many of you got 210 centimeter cube? Okay, very good. Now, the capacity is simply 410 divided by 1,000. And this is equal to 0.1 liters. Both answers.
Mr. Michael, can I go to the toilet, please?
Well, please, what did you say?
Can I go to the toilet, please? May I go to the toilet?
Yeah, quick. Okay, guys. Take it. What is the volume of each of this? What is the volume of this? You can see one of these is 1 cm cube. So what will be the volume? So guys, do this because you're doing the counting. You're finishing in 10 minutes. 10 minutes. Everyone in the class, can you see it properly or I should make it bigger?
Yes, I'll call.
Thoughts in your mind.
Right, yeah, don't miss out. I don't miss
It's harder that we can't number in 10 pounds.
Is that you? Mr. Bella, is that you? Okay.
We can assume that. Yeah. Yes, we can.
Six, 9, 4, 1, 2, 3. Wait, 1, 2, 1, 2, 3.
You're counting out loud, really loud, please. One minute, you count.
Yeah.
Keep counting out loud, you're distracting other people when they're counting as well.
Number 9, uncle.
Just wait.
Number 9, could it be possible squares behind that?
I would assume that, where there's squares at the top, there's squares underneath. If that makes sense. So here's a square, that means there will be squares all the way to the bottom. But because there's no squares here, I would say there's no squares there.
If you count just the top, does that mean you can times it by 3?
One, two. We can have an example and that question comes, you can't speak out loud, but you'll think you're giving the answer now.
Put the timer. Oh, that's okay. So that means you've got 5 more minutes. Let's say 6 more minutes.
Check number 4.
Yeah, that's the one. I can show them.
Yeah.
Listen.
6.
I'm not gonna check everyone's answer, but I'm gonna check.
I get so many different answers for four.
I think that's the hardest one on the. You don't have to have everything you want.
The hardest one is wait, you might have Yeah.
Number 4.
Oh, yeah.
There's 4 here. That's 4 right there. But there's 2. So that's 8. And you 8 times 2 is
16.
16. Okay, so then we're gonna, what's this? 4 times 3 is
12.
and then 12 plus 16.
24. 28.
You sure? 28? And then 28 plus how much is that?
16.
16. Oh, what's that? So if you're able to divide like the sections into little bit and then add it up, it's easier. Instead of you having to, you know. Pardon? Which one? This one? Because look, it goes like this. Well, look, there's 3 here. So do you get? So if you can divide them into different sections and then add them up, it'll be easier than trying to count all of them, because you can lose your count. Does that make sense? Right or wrong? Do you understand this? You keep your answer. Wait, what you put?
I crushed out for about 4 minutes. But I was like,
Okay.
Working on this? Is anybody still working on this?
yes.
Let me see your hand up if you're still working.
So everyone's finished, and Joel's still working on it.
Okay, 2 more minutes.
I'm on the last question though.
Okay.
Okay, but just look at this. Like this, so there's 4 here, but there's 2. So 4 times 2. Okay, but this is times 2 up. No, so 8 times 2 is. Okay, so just remember number 16, yeah? That's the bottom. Now, for this middle level, you have 1, 2, 3. 3 times 1, 2, 3, 4. 12. So we're gonna add 16 and 12, which is okay. And 8 plus this. This is the same as this, right? Yeah, so 28 plus. So 28 plus 16. Huh? 28 plus 16. Yeah. So do you get how we get that? Yeah. Joe, do you understand? Yeah. check the number 9.
If I get number 9, wait, Uncle, did I get number 9?
All right, so guys, before our time is nearly up. So let's see. Number 1. Let's see how we do this. Let's count. All we just need to do is note the ones that does not belong to the lot. Now there is 2 here and there is 2 here. So anything we count plus 4. So let's see. This is 1, 2, 3, 4. All right, and then we've got another 4 underneath. So that would be 8 plus 4, and that is 12. Number 1 correctly. Let me see your hand up. Very good. So let's see. This is 1, 2, 3, and this is 1, 2. That means underneath we've got 6. All right. So let's count 1, 2. This is another 1, 2, and 1, 2. So this is 4, and this is 1. 1 plus 4 plus 6 is. Yes, Christabella.
I'm confused. Isn't number 1 10? Because you're the one
Is more.
What if there isn't one behind it?
Can I assume that it's something?
So, but then there's something on top of
Because
it.
they're not, yeah, they're not crumbled.
Now, Christabella, look at me. Christabella, look at the screen, Christabella. There are 2 behind this. This is 2. There's 2 inside here. Yeah. So that can look for what is underneath. And then, so let's see this. Just like this, Christabella. Christabella, look at this is 1, 2, and this is 1, 2. So that means there are 4 here. So you can only see 3, isn't it? There is 1 underneath this one. Does that make sense?
Yeah.
This is 1. So 1 plus 4 is 5.
Yeah.
So let's we have 1, 2, 3, 4. And we have 1, 2. This layer, there are 8 cubes. All right, that is 2 times 4, that is 8. So let's see for this layer, 1, 2, 3. And 1, 2, 3. So for this, 3 times 4 is 12. Now, the bottom layer, we have 1, 2. All right, and we have 1, 2, 3. We've got
The other side on the same view.
this is 1, oh, sorry, 1, 2, then 1, 2, 3, 4. Yeah. Oh, this is 1, 2, 3, 4. This is 4 times 4, that is 16. So everything here is 36.
Six? How is it 4? You said it was 44.
No, wait, he hasn't added the 8 from the top. Wow.
All right. 5.
Mr. Michael. For number 4, at the top you put 8, but it's meant to be 8 times 2 because of the.
Oh yeah, it's
8 on
16 too. It is. So 16 plus 16, 30, 44. So guys, at this point, I want you to pack up your books, right? So when you watch the video of the lesson, you will see the correction, all right? So pack up your books and go to the front room, please.
pack up and then line up. What's a great phone? On your jacket, don't leave on the floor.
You can leave to the main room, go to the main room.
Thank you, Mr. Michael.
Thank you, Emmanuel.
Thank you, Mr. Michael, for having me.
See you next week. Not going to. Jason, do you want to watch me do this or you want to go back to the main room? Okay, 4, and then plus 1, 2.
Wait, never mind. I understand it now.
Okay, that is 6. So this plus this is 30.